Hi, I'm Dr. Papia Bhattacharjee. In this problem, we have this function. It's a function of two variables, x to the 4 minus 2xy plus 3y cubed. And we have to compute the second partial derivatives, and there will be 4 of them. Now, of course, to compute the second derivatives, we have to first compute the first derivatives. So let's call this function f of x comma y, and we will use the notation fx to denote the first, one of the first partial derivatives of the function f. So what is fx is the partial with respect to x of this expression, the function x to the 4 minus 2xy plus 3y cubed. Okay. Now, recall that this is a partial derivative, and therefore, since we are taking the derivative with respect to x, all the other variables are considered constant. So that means the variable y will be considered constant. Okay. So let's compute this derivative. So the first term is x to the 4th, and this is with respect to x, so we have a derivative 4x cubed. Now for the second term, we have 2xy. So 2 is a constant and y is also a constant, remember. So you pull out 2y and take the derivative of x, which is just 1. For the last term, there is no x, so the entire term 3y cubed is a constant, and derivative of constant is 0. So the first partial derivative with respect to x is 4x cubed minus 2y. Okay. Now let's compute the second one. So fy. What is the partial derivative with respect to y of this function? Okay, now we are taking the derivative with respect to y, and therefore x will be considered constant. So keeping that in mind, let's look at each term. First term has x to the 4th, no y at all. So this is, the entire thing is constant, therefore the derivative is 0. For the second term, see the negative 2x is a constant, and the derivative of y is 1. For the third term is 3y cubed. You can just use the power rule to say this is 3 times y cubed is 3y squared. So simplifying this, we get negative 2x plus 9y squared. So that's the first partial derivative of the function with respect to y. Okay. Now we have to compute the second partial derivatives, which is the derivative, partial derivative of this expression and this expression, right? So let's compute that. So for fx, we will be taking the partial derivative with respect to x and with respect to y. So the first one is fxx, and that is partial with respect to x of fx. So 4x cubed minus 2y. Okay. Again, recall this is with respect to x, and therefore y is considered constant. The first term has x in it. 4 is a constant, pull it out. The derivative of x cubed is 3x squared. For the second term, 2y is a constant, so the derivative is 0. And so this second partial derivative is 12x squared. Okay, let's compute fxy, and that is partial with respect to y of fx. So of 4x cubed minus 2y. And now since this is a partial derivative with respect to y, x is considered constant. So this first term, the whole thing is constant. So the first term derivative is 0. And for the second term, it's negative 2 and derivative of y is 1. So simplify this, we just get negative 2. So we got 2 second partial derivatives. Now we have to get 2 more from fy. Okay. So same thing again, we will take the expression for fy, take the partial derivative with respect to x and with respect to y. So the first one with respect to x is fyx. So with respect to x of negative 2x plus 9y squared. Okay. First term is negative 2x and you're taking derivative with respect to x. So pull out negative 2, derivative of x is 1. Second term, the entire thing is a constant because there is no x. So the derivative is 0. Answer is negative 2. Finally, we compute fyy, and that is partial derivative with respect to y of fy, that is negative 2x plus 9y squared. And in this case, the first term, the entire thing is a constant because this is with respect to y and this has no y. So derivative is 0. Second term, pull out 9, derivative of y squared is 2y. So the answer is 9 times 2, 18y. So we got all 4 second partial derivatives of this function. Thank you.